G'day, this here is question 4 and it's on page 167 in your SciPad. Alright, first thing we need to do is make a list. So we've got a student has attached a 100-gram rubber bung. So we'll write down that M is equal to, and instead of 100 grams, we'll write it as 0.1 kilograms. And it's attached to a 1.2 meter length of string. So we'll write R is equal to 1.2 meters, and swung it around her head with a constant speed at a horizontal circular motion. The bung completes 10 loops in 10 seconds. So lowercase t is equal to 18. Big T, which is the time period, so that's the time for one loop, is going to be 18 divided by 10, which is 1.8 seconds. So that's what time period is, and that's one that will be useful for us. Our question here is calculate the size of the net force acting on the bung. So F is equal to question mark. Now we'll go with our first thing we might need to do is find our velocity. Okay, we'll just point out here, it says draw and label the bung's velocity. So that's velocity is going there because the bung's going this way, velocity is drawn tangent. The force is towards the center because the person's pulling on the string. The person stops pulling on the string, the bung would carry on in that path there. But as long as they're pulling on it, the bung keeps accelerating in a circle. So remember, even though it's traveling at a constant speed, because it's changing direction and velocity is a vector quantity, that means that it's classed as acceleration as it goes around. Force and acceleration, and indeed change in velocity, all of those things are towards the center of the circle. So that deals with that question. So now we're going to calculate the velocity, because that's something we're going to need in order to find force, because our formula for force, which we'll be able to use later, is F is equal to mv squared over r. And at the moment we want to find F. We know m, we know r, but we don't know velocity. So we're going to have to find velocity. Velocity is done using a modified version of velocity as distance divided by time. So to find the distance it travels around the circle, we've got to use the circumference of a circle formula, which is 2 pi r. So 2 pi r is the distance around, and instead of the time for 10, we've found the distance for 1, so we have to use the time for 1. So we come back to here where I got it already before, so it's divided by 1.8. So the velocity is 2 pi r divided by 1.8, and r on this occasion, we'll write it out properly. R was 1.2 divided by 1.8, and if we put that into our calculator, and we get 4.188, and that's ms minus 1. We'll just leave that one unrounded because really our goal here is to find the net force. So now we can come down to this formula. We put in our mass, which has been put into kg, so 0.1, times it by 4.188, just using the number from our memory before. And we've got to remember to square it, common error, and then we divide it by the radius, which is still the same at 1.2. And that gives us the answer of 1.461. And then we'll check for our rounding. We can see we've only got 2 significant figures there. Got 2 there. That means our answer is going to be 2. So our answer will round to 1.5. Because it's a force, it is measured in newtons. And that is the end of the answer.